Our second video is representation of discrete time signals. What is discrete time signal? A discrete time signal are defined on the discrete instance of time. What are the other type of signals? That is continuous time signal. They vary continuously with respect to time. Now, in this video, we are going to see how we can represent different types of discrete type signals with different ways. Four ways of representation we have. The first way of representation is graphical representation. Secondly, we have functional representation. Third, tabular representation. And the fourth one is sequence representation. Moving on to first representation, that is graphical representation. Now, this is a graphical way of representing the signals. Now, given it is x of minus 3 equal to minus 2. Now, we are drawing two axes, x of n with respect to n, and we are plotting the values in x-axis minus 3, minus 2, minus 1, 0, 1, 2, 3. Now correspondingly we are marking, as such we will mark in a graph. That is minus 3 is given that it is the value is minus 2. X of minus 3, the value is minus 2. Now it will be coming at the down, so we are marking it as minus 2. Now the second one is x of minus 2, which is equal to 3. Now it is coming at the top, so we are marking it at the top, drawing a line. Next, it is x of minus 1. Minus 1 is equal to 0. The value is marked here. Similarly, x of 0, which is minus 1, x of 1, which is 2, x of 2, which is 3, and x of 3, which is 1. Now, this is the graphical way of representation. Next is a functional way of representation. In this, the amplitude of a signal is written against the value of n. Now we have n values. The value of n is equal to 1 comma 3, that is for the values of 1 and 3 the x of n value is 4, and n equal to 2 the value of x of n is equal to minus 2. Now the value is 0 for all other values. Now this is the functional way of representation. Now next one is tabular representation. Now it is represented in a table form, that is where we can draw a table with respect to x-axis and y-axis. X-axis value is n, y-axis value is x of n. Now we are writing all the x-axis values and corresponding values we are writing here in terms of x of n in a tabulation form. It shows minus 2 for minus 2 the value amplitude is minus 3. Minus 1 the amplitude is 2, 0 the amplitude is 0, 1 the amplitude is 3, 2 the amplitude is 1, and 3 the amplitude is 2. Now this is a tabular representation. Next is sequence representation. Now in sequence representation, we are writing everything in terms of sequences. Now here x of n is equal to 1 minus 1 0 4 minus 2 4 0. Now n is equal to 0, which specifies the 0th position. Now if the arrow is not given, the first value will be taken as the 0th value. Now delayed by 2 samples, that is x of n minus 2, which is it will point to the 4. Now advanced by 2 samples x of n plus 2, it will be pointing the next after 2 positions still point the value. Now where the arrow specifies the 0th position. Now this is the sequence representation, and Up to this, we have covered the representation of different discrete time signals. Thank you.